The vacuum tube is the fundamental element in all modern communication devices. Long-distance telephone, public address system, electric phonograph, sound motion picture, radar, radio transmitter, and radio receiver. First, let us consider how a three-element vacuum tube, the triode, operates. A tungsten filament extends into a tube such as this. A cell supplies a current which heats the filament. When the filament gets hot enough, electrons are emitted. The electrons build up a space charge in the tube. As the charge builds up, electrons are repelled back to the filament, and finally as many return as leave. Now let us add a second element called the plate. Actually, the plate is a metallic cylinder surrounding the filament. The plate is connected to the positive side of a high-voltage battery. Since the plate has a positive charge with respect to the filament, electrons are attracted to the plate. A stream of electrons thus flows from the filament to the plate inside the tube, to the battery, and back to the filament. This is the plate circuit. If the voltage on the plate is increased, the plate current will increase since more electrons will be attracted because of the higher positive charge. With ordinates representing voltage and current, we can trace a curve to show this relationship. Note the saturation point, beyond which there is no increase in the plate current, even when the voltage is increased. A third element of wire mesh, called the grid, is inserted between the filament and the plate. Now let us connect a battery in the grid circuit so that the grid can be given a large positive charge. The pull of this positive charge is added to that of the plate, and more current flows. Electrons moving from the filament to the plate pass through the spaces in the grid. If the grid is made less positive, the plate current decreases. Even if the grid is made slightly negative, electrons can still flow from the filament to the plate. But if the negative charge on the grid is increased to a certain point, no electrons can flow, and the plate current falls to zero. Thus, the amount of plate current flowing depends upon the kind and the amount of electrical charge on the grid. Now let us connect the grid and the filament to the secondary coil of a transformer, whose primary is connected to an aerial. We know that the current in the coil is a high-frequency alternating current. When electrons flow off the grid becomes more positive with respect to the filament. When the current reverses and electrons flow onto the grid becomes more negative. Thus, the charge on the grid will change at the same frequency as the radio frequency current. We have already seen that when the grid swings more positive, more plate current flows. And when the grid swings less positive, less plate current flows. The plate current, therefore, will rise and fall at the same rate as the radio frequency current in the grid circuit. Such a current is called a pulsating direct current. The vacuum tube may be used to amplify the weak voltage induced in the aerial circuit. Its use as an amplifier is possible because a small change in the grid voltage brings about a large change in the amount of plate current. The grid, therefore, actually controls the powerful current generated by the high-voltage battery. The plate of the amplifier tube is connected to a load supplied by the primary winding of a transformer. As the plate current increases, the voltage across the primary increases. As the plate current decreases, the voltage across the primary decreases. Thus, the voltage across the primary coil will vary with the amount of plate current. These voltage variations are much greater than the voltage changes in the grid circuit. These voltage variations in the primary coil are transferred by induction to the secondary of the transformer, which is connected in the grid circuit of the next tube. Thus, the small changes in voltage on the grid of the amplifying tube have brought about large variations in the voltage impressed upon the grid of the next tube. Thus, we can say that the tube has acted as an amplifier. The vacuum tube may also be operated as a detector. When used for this purpose, the grid bias is adjusted so that the operating point of the tube is just below the straight portion or knee of the characteristic curve. As a result, the positive half cycle of the radio frequency current in the grid circuit is amplified much more than the negative half of the cycle. The average plate current resulting from the unequal amplification of the positive and negative half cycles will be a direct current pulsating at audio frequency. Such a current will operate the earphones. Here is a diagram of a simple receiving set which uses a crystal as a detector. The vacuum tube is more efficient than a crystal because it also acts as an amplifier. If we wish a louder signal, we may add a radio frequency amplifier ahead of the detector. A still louder signal may be obtained by adding an audio amplifier after the detector. We can now use a loudspeaker instead of headphones. The vacuum tube is also used in the transmission or sending station to generate radio frequency currents. In a tickler-type oscillator, the grid circuit contains a coil and a variable condenser. The plate is connected through a coil, B battery, and a key to the filament circuit. When a current flows through the plate coil, the magnetic field of this coil sweeps across the grid coil and induces a voltage in it. This happens when the key is pressed. As the plate coil field builds up, electrons flow away from the grid. Thus, the grid becomes less negative and more plate current flows. When the plate current reaches maximum, there is no change in the field, hence no current is induced in the grid coil. The field of the grid coil collapses and helps to charge the condenser. Now the condenser discharges, and the radio frequency current in the grid circuit changes direction. The grid becomes less positive, and this reduces the plate current. The collapsing field of the plate coil assists in building up the current in the grid circuit. As the grid reaches a high negative charge, the plate current is virtually cut off. The field of the grid coil collapses and charges the upper plate of the condenser. This completes the entire cycle. The frequency at which the current alternates is determined by the resonant frequency of the grid circuit, which may be controlled by a variable condenser. The current may alternate millions of times per second. Direct current from the B battery is thus changed to a high-frequency alternating current in the grid circuit. The grid circuit of such an oscillator may be coupled to an antenna in the sending station. Energy is transferred by induction from the grid circuit to the aerial ground circuit, and electromagnetic waves are radiated out into space.